Hey guys, today we're going to start our second chapter, which is on equations. I know you guys have dealt with equations last year, which is great. From what it sounds like, you guys only dealt with two-step though. So today we'll be talking about one-step and some two-step equations. And then as we continue forward, we'll look at our multi-step and our variables on both sides. A huge term that you need to know when dealing with equations is something called inverse operations. So inverse, it's pretty much meaning that we're taking two things and they're going to cancel each other out. And what specific things are we looking at to cancel each other out are our operations. So I know if I'm adding, if I want to cancel out addition, I will use subtraction. And it goes the same both ways. If I am subtracting, I can use addition. Another one that we know of is multiplication. If I'm multiplying two things together and I want to get rid of that other thing, I can use division to cancel it out. And then the same the other way with division. Multiplication is its inverse operation. Mathematics is pretty much just learning something new and then learning how to undo it with its inverse operation. In calculus, there's a theorem called the fundamental theorem of calculus, and it sounds like this big grandiose thing, but then you just find out that it's, an integral is the inverse of a derivative, and it's nothing too overly fancy. So our goal for solving x is to isolate the variable by using inverse operations to both sides. Now, isolate means to get it alone. Variable, as we learned in our last chapter, is an unknown value represented by a number. So we want to get that letter represented by a letter, not a number, represented by a letter by itself. So we're trying to get our letters alone. The following instructions say to solve the following equations and to check your solutions. If this is on a test and you don't check your solutions, you will get a point taken off. Some people have lost like 12 points because they didn't check their solutions throughout the entire test. Make sure we're checking our solutions. Starting off easy, you can look at the first row. These are all one-step equations. If I have x plus 3 is equal to negative 2, I want to get the x by itself. So what's going on with the x? I'm adding 3 to it. So on both sides of my equation, I'll subtract 3 to cancel out this constant here. With that constant gone, now I'm just left with the x. And then I have negative 2 minus 3, or negative 5. I could go ahead and check this. Take this negative 5 and substitute it in for x up here. I'd have negative 5 plus 3 is equal to negative 2. Negative 5 plus 3 is negative 2. Oops, what am I doing here? So we're equal on both sides. That checks out. Looking at our next one. I have y minus 1 is equal to 9. So you have to look at the operation going on between y and 1. I am subtracting here. So my inverse operation to subtraction is addition. So I will add a 1 to both sides. By adding a 1 to the left side, all that's doing is just canceling out this minus 1 here, leaving me with just my y. On the right side, I have 9 plus 1, which is 10. Y is by itself, so I have y is equal to 10. I do need to go ahead and check by substituting this y up in here. I'd have 10 minus 1 is equal to 9. 10 minus 1 does equal 9. Both sides are now equal. It checks out. (5z) is equal to 35. I do not see an operation between the 5 and the z. That means that we are multiplying these two. So if you do not see any sign, that means you're multiplying the two. So my inverse operation of multiplication is division. I'm going to go ahead and divide both sides by 5. By dividing the left side by 5, all I'm doing is just canceling out this other 5, giving me z by itself. On the right side, I have 35 divided by 5, or 7. Z is by itself, so I'm done solving. I have z is equal to 7. However, I do need to check by substituting z. 7 in for z. So I'd have 5 times 7 is equal to 35. 5 times 7 does equal 35. 35 does equal 35. Or checking. Excuse me. And then the last one is in this row, I have x over negative 8. To get rid of that negative 8, I have a fraction bar between the x and the negative 8 there. That fraction bar really just means division. That's a division bar. So I'm dividing the two. So my inverse operation would be to multiply by negative 8. By multiplying by negative 8, these two cancel out on my left, giving me x all by itself. On the right side, I have negative 4 times negative 8, or 32. X is by itself. I have x is equal to 32. I do need to check though. Substituting this 32 in for the x up here. I'd have 32 over negative 8. Does that equal to negative 4? Yes, it does. She checks. Smiley face. And those are our 1 steps. It's funny because later on we start working with like a bit harder problems, and then I give you guys a 1-step equation and you don't know what to do. Make sure we don't forget the easy ones too, guys. All right. All right. Scrolling on down. Now we have our 2-step equations. I like to break these up into like little like a little steps. First step is to get rid of your constant. Get rid of constant. After you get rid of your constant, you can go ahead and get rid of coefficient. So we get rid of the constant first, then we get rid of the coefficient, and then be sure to check. Ooh. Come on. Check. So first I want to get rid of my constant, which is that 5 there. What's going on with the 5 though? I am subtracting 5. So I have to use my inverse operations. The inverse of subtraction is addition. So I will add 5 to both sides. Cancel those guys out. Leaves me with 4x. On the right side, I have negative 45 plus 5, or negative 40. So now I have 4x is equal to negative 40. Now I need to get rid of that coefficient. I just have 4x here, which means I'm multiplying. So the inverse operation would be to divide. On the left side, when I divide by 4, that's just canceling out the 4's, giving me x. And then on the right side, I have negative 40 divided by 4, which is negative 10. X is by itself now. I have solved my equation. I can now go ahead and check by substituting negative 10 in for x here. So when I check, I'd have 4 times negative 10 minus 5, and I want that to equal to negative 45. You will have to use some kind of like order of operations. So I have 4 times negative 10, which is negative 40. And then I have negative 40 minus 5, which is negative 45. And that checks out. So negative 10 is my solution. One-third x plus 6 is equal to negative 8. 1/3 x plus 6 is equal to negative 8. Same thing as last time. I need to get rid of my constant first. My constant here is that 6. In the problem, I am adding 6. So its inverse would be subtraction. I will subtract 6 from both sides. Cancel them. I have 1/3 x is equal to negative 8 minus 6 is negative 14. All right. I have 1/3 x is equal to negative 14. I'm multiplying that 1/3 and the x. So to get rid of it, I can just divide by 1/3. That cancels these two out over here, leaving me x by itself. On the right side, I have negative 14 divided by 1/3. When I divide by a fraction, it's the same thing as multiplying by its reciprocal. So I could say that this is negative 14 times 3 over 1, or just 3. So negative 14 times 3 is, like negative 42? Yeah. X is by itself, there's my solution. However, I do need to check. So I need to take that negative 42 and substitute it back into the original. So here's my check zone. I have 1/3 times negative 42 plus 6, and I need that to equal to negative 8. So 1/3 of negative 42, negative 14. Negative 14 plus 6 is negative 8. Negative 8 equals negative 8, so that checks out. That is the correct answer, negative 42. All right. The quantity x minus 7 all over 3 is equal to negative 12. Now before, I said, hey, let's get rid of the constant first and then the coefficient. This way it's a little different. I know you guys are a huge fan of fractions, and I love that, and we should keep that going. But it's a lot easier when you get rid of the fraction first here. So like I said before, that fraction bar is really just a division sign. So if I want to get rid of that 3, I could just multiply both sides by 3 first. That dividing 3 times 3 would cancel each other out, leaving me with now just the top. That's only working because both the x and the negative 7 there are being divided by 3. So if it was something like this, you couldn't do this. You'd have to make sure that the whole thing is being divided by that 3 first. I have negative 12 times 3, which is negative 36. Now I'm just left with that simple one-step equation. I'm subtracting the 7. I can go ahead and add 7 to both sides. X is equal to negative 29. X is all by itself. I can now go ahead and substitute this boy back into x in the original problem in my check zone. I'm going to get that going this year, check zone. So I have negative 29 minus 7 all over 3 is equal to negative 12. Order of operations, we're going to simplify the numerator first. I have negative 27 minus, negative 29 minus 7, negative 36. And then I'm dividing that by 3, which is negative 12, and that checks out. And there they are, they're so cute. We could just jump this up a little bit. I have 4 times the quantity of x plus 3 is equal to 12. Now, there are 2 different ways that we can solve this. Because I'm multiplying the 4 there to the x and 3, I could go ahead and distribute this. I'd be left with this scenario, where I have 4x plus 3 is equal to 12. And then this is just like one of the first problems that we looked at. I can subtract the 3. Then divide by the 4. And I'm left with 9/4. Or 2.25. Yeah. Or I can go a different route where I divide both sides by 4. So I'm starting off here. And I'm going to divide both sides by 4. Because the distributive property is really just multiplication, by dividing, I'm just canceling out those two 4s. Just giving me that parentheses part. And then that equals 3. Did I mess up over here? They should be the same answer. Oh my goodness, why didn't you guys say anything to me? I didn't distribute properly. That should be a 12. Ugh. You guys should have said something. Zero. And then this one, you get the same answer then. I like this way more. It's only 2 steps to solve it. This one, you need 3 cute little steps. But, I mean, both ways you get the same answer. The one way you get to practice the distributive property, so that's pretty nice. The other one you're kind of just using that you know it's the distributive property. But, yeah. So for this next one, I could distribute that negative 6/5 in. Then I'd have like really gross fractions because we'd have negative 6/5 times 3. Or I could just divide both sides by negative 6/5. That cancels these two out, leaving me with just x plus 3. Again, when I divide by a fraction, it's the same thing as multiplying by its reciprocal. So 6 divided by negative 6/5 is the same thing as 66 times negative 5/6. If I want, I can put a 1 over here. I can simplify this before I start multiplying. I really have 11 times negative 5, which is negative 55. I can subtract the 3. Oops. I get that x is equal to negative 58. Excuse me. I can go ahead and take this negative 58 and substitute it back into the original up here. So here's my check zone. So I have 66 is equal to negative 6/5 times negative 58 plus 3. Order of operations, I'm going to do what's inside the parentheses first. Negative 55. Then I have negative 6/5 times negative 55. Again, I can change it to a cute little fraction. Simplify it before I do anything. I get 66. We're equal on both sides now. That checks out. Uno más. Yeah, we're going to worry about those 2 bottom ones later. Uno más. I have 2 times the quantity x minus 9 all over 5 is equal to 4. Just like that one above it, I want to get rid of the fraction first. So I'm going to get rid of that 5 by multiplying both sides by 5. I'll just cancel these 2 out. I'm left with 2 times the quantity of x minus 9 equal to 20. I could go ahead and distribute that 2. I'd be left with 2x minus 18 is equal to 20. And I can solve it that way. Or I can just divide both sides by 2. Now cancel these 2 out. I'd have x minus 9 is equal to 10. And then I can add 9 to both sides, giving me x is equal to 19. How do I know that's the correct answer, though? By going to the check zone. Check zone. I'd have 2 times 19 minus 9 all over 5 is equal to 4. Order of operations, I'm going to do what's in the parentheses first. So I have 2 times 10 over 5 equal to 4. 2 times 10 is 20 over 5 equals 4. 20 divided by 5 is equal to 4, which is equal to 4. So I do get 4 on both sides. They check out. That is my correct answer. gorgeous. Okay. We're going to worry about problems like those sometime in the future. I have something on Schoology for you guys. It's like a cute little maze. I thought we could look at it together just real quick so you know what you're doing. There's your Schoology. Two-step equation maze. So you're going to start in the start section. You're going to solve it. Check your solution too. Does it even say, oh, it says show all your steps, but check your solutions. And then your answer is going to be one of these 3 avenues. And then whatever that answer is, you just follow that one, and then that's your next problem. So for example, if I solve this first one here, and I think my answer is 9, I'm going to go down to this one here, and solve x minus 7 over 4 is equal to negative 2. And it's either going to be 14 or negative 14. And I'll just keep going that way. Okay? There should be enough space in here that if you zoom in, you can do all your work right there. But if you'd like to do your work on a separate sheet of paper, you're more than welcome to do that. I recommend then just scanning it, so then I can get your work then too. Okay? You are handing this in then too. Thanks. If you have any questions, please let me know. Okay.